Hi, I'm Chris with Sanderson Test Prep, and as we continue our series on graphing polar equations, we're going to take a look at Limacons. So let's take a look at our general equation that lets us know that it's a polar equation that's going to have this particular shape. And this will be whenever we see that r equals a plus or minus cosine theta, or r equals a plus or minus b sine theta. So that's our general structure. And let's take a look at which orientation we would expect for each. And this is going to be very similar. In fact, in terms of the orientation itself, the shapes will change a little, but the orientation is going to be just what we saw with circles, which if you're looking at your cosine values, a positive cosine means that the orientation is going to point out to the right along the horizontal axis, and a negative would point out to the left. And then for your sine values, a positive would mean the orientation is going to be upwards along the y-axis, and a negative means that your shape is going to point downwards along that y-axis. So hopefully that's familiar to us. If you haven't yet checked out the video on graphing circles from polar equations, then please take a look, and hopefully that will become a little bit more familiar to you. But now let's take a look at how these values of a and b are going to help dictate the shape that we're going to see in our polar equation graphs. So we'll take a look at these four scenarios, and we'll start with something that's going to have an inner loop to its shape, which is going to occur when a over b is less than 1. So when a over b is less than 1, and keep in mind a and b are always going to be positives here, because in the equation itself, even if it's a minus b sine theta, for example, the minus is part of the equation, but the value of b is still a positive value. So a over b, if it's a fraction, less than 1, then you're going to have this inner loop, which means it'll have this general shape. And this would be for a positive cosine function. And obviously this would change in its orientation. If you had a negative cosine, it would be the same shape pointing that way, positive sine, negative sine, etc. But for right now, we'll put everything in terms of positive cosine, just so we can make sure that we understand the shape. Right now, all we want to do is understand the general shape that we're going to expect for each of these scenarios. So when a over b is less than 1, you're going to have this shape to your limacon, which is going to contain this inner loop that we see here. And this is kind of a unique feature that we see when a over b is less than 1. Now let's take a look at a different shape, which we refer to as a cardioid. And a cardioid is basically going to occur where that inner loop is taken out. So if we sort of skip the inner loop part of it, then we would have this general shape, and it's going to kind of pinch in sharply. And you can kind of see it's the same as that inner loop shape, just without the loop. So here, when it's equal to 1, we're going to take out that inner loop. And this is the general shape that we would have when a over b is equal to 1. Now what about when we get something greater than 1? How's that going to change the general shape? Well, basically, the larger the value for a over b, the more that you're going to take out that sharp pinch, and the more it's going to become a subtle dimple. So here, you're going to have something that basically kind of comes in like this. So you'll see this more subtle dimple. Instead of it pinching in very sharply like we had with the cardioid shape, when you have a value between 1 and 2, you're going to have a dimple. So this is basically that sharp pinch is being pushed outwards a little bit. So instead of that sharp pinch, we're going to have a more subtle dimple. And then when a over b is greater than or equal to 2, this one's going to look almost circular. So I'm going to try to draw this. It's not going to be perfectly circular, but almost circular. So an even more subtle dimple. And if you think about that, think of a over b as a measure of how deep the dimple is. So even picture somebody smiling with dimples. A over b value that's very large means less of a dimple, and a smaller a over b value means a more indented dimple. And that's exactly what we see when we compare these four shapes to each other based on those values of a and b. So that's a good understanding, hopefully, of the general shape that we can expect for these Limacon graphs. And in our upcoming videos, we're going to take a look at how to draw an accurate graph using the actual numerical values for a and b with a couple sample questions, so that we can see exactly what scale we need to put along our x and y axes in order to accurately graph each of these corresponding shapes. But for now, make sure you memorize what kinds of shapes you're going to have for the different values of a over b. For more, please check out our other videos, and thanks for watching.